First question, if the elevation of a waveguide platform, it is 55 meter above the sea level. So now we have a waveguide platform which is 55 meter above the sea level. So these are sea level, suppose. These are waveguide platform which is 55 meter above the sea level. And the age of the erosional surface, it is 120 kilo year. So the age of the original surface, it is 120 layer. So the height of the waveguide platform, it is given 55 meter. That means to uplift 55 meter, it takes 120 kilo year. So you have to calculate the rate of upliftment. So it will be height or distance it is uplifted divided by time it is taken. 55 meter divided by 120 kilo year. It will be 0.458. So you have to give answer into 2 decimal. So you will only write down 0.45 as answer. Next, fine modes are deposited at a rate of 1 centimeter per 1000 years. So it is deposited 1 centimeter per 1000 year. So assuming a constant sedimentation rate, that means each 1000 year it is depositing 1 centimeter. So if there is absence of compaction, then what time it will take to deposit 1 kilometer thick sequence? The simple thing, 1 centimeter it is taking 1000 years, then 1 kilometer will take 1000 into 1 kilometer in centimeter, it will be 10 to the power 5 year. It will be 100 into 10 to the power 6 year. So 10 to the power 6 here, you can convert it into million year. It will be 100 million year. So to deposit 1 kilometer thick sequence, it will take 100 million years. Then a continuous 10 meter thick sequence, we have a 10 meter thick sequence of shale. So this is 10 meter. So it was deposited in 10,000 years. So this 10 meter thickness of shale, it takes 10,000 years to deposit. So deposition is it at a uniform rate. So the number of samples that must be collected at equal stratigraphic interval to sample the succession every 500 years. So if we take sample in every 500 years of these deposits, so we will take 20 samples. But the whole deposition it takes 10,000 years. If you take every sample in 500 years, then you can take 20 samples. Then in an ocean basin, 4 million year old oceanic crust, it lies 40 kilometer away from the ridge axis. So this is a ridge axis. So suppose this is the point where it is 40 kilometer away from the mid oceanic ridge axis, and it is 4 million year old. So the plate average velocity of the plate So this crossroad part, before it was at this ridge axis. Gradually it is drifted. So we can calculate the velocity by taking distance by time. That is, distance is given 40 kilometer. Time it is given 4 million year. 40 into 10 to the power 5 divided by 4 into 10 to the power 6. So it will be, this will be centimeter, this will be year, 1 centimeter per year. So here the given section with the uniform lithology. So there are two records of ash layer dated 77 million year, one another is 76 million year respectively. And index fossil species present in the lower part of the section become extinct at a horizon of 7 meter. So what will be the estimated age of the extinction event? So you have two events. One is 77 million year, another is 76 million year, which has an interval of 2 meter it is. That means the deposition of 2 meter, it is taking 1 million year. That means this is one ash layer, this is another ash layer. So first this ash layer will deposited, then again after 2 meter interval, another ash layer has age of 76 million. So each 1 meter we are getting 0.5 million year interval. Now this horizon, it is at you can say 7 meter height, where the interval will be 4. That means the age of this extension will be 74 million year, because each 1 meter interval the age will decrease by 0.5 million year. There are 4 interval, so here the age will be 74 million year. The answer will be 74 million years. And within a fourth order drainage basin, the total length of the first order, second order, third order, fourth order. So total length of first order, second order, third order, and fourth order, it is given. So total length of first order, it is given 10.5 kilometer. Then 7.5 kilometer it is second order. Then 5.5 kilometer it is third order. Then 1.5 kilometer is fourth order. Then the drainage density, it is given. Drainage density is given 0.5 kilometer inverse. So you have to calculate the basin area. So we know drainage density, that is kilometer per inverse. It is equal to total length of all stream present. So it will be 25 kilometer, the length of all stream, 25 divided by area. So area will be 25 kilometer divided by 0.5 kilometer inverse. It will be 50 kilometer square. So area will be 50 kilometer square. Then another question, a drainage basin of fourth order covers area of 40 square kilometer. This area is given 40 square kilometer. Then same to first order, second, third, and fourth order stream length is given. First one is 12.5, second order it is given 8.8. Then third order it is given 4.7 kilometer. Fourth order it is given 4 kilometers. So we have to calculate the drainage density. We have to calculate the drainage density. So the drainage density, the length by area, it will be length by area. So drainage density, it will be length by area. 30.3 kilometer divided by 40 kilometer square. It will be 0.7575. So you have to only give answer into 2 decimal. So you have to only write down 0.75 as answer. This is kilometer. In a sedimentary succession, as shown in the figure, the last occurrence of fossil species Q, it has dated 50 million years, and at the first occurrence of the fossil species R is 30 million. So here the age is 30 million years, and the age is 50 million years, and the difference between the depth is 40 meters, and the difference between the age is 20 million years. So you have to calculate the estimate rate of sediments. So the depth difference or the thickness of this deposition is 40 meter. So to deposit 40 meter, it takes 20 million years. So we can calculate the rate of the sediments. The rate of sediments will be 40 meter divided by 20 million years. It will be 2 meter per million years. The answer will be 2 meter per million years. So in a structural control fluvial setting, an asymmetrical flight of the river terrace, T1, T2, T3 is given. The age of the sample at L1 was 30. Okay, so here the age is 30 kilo years. So assuming that it formed due to deformation, so we have to calculate the average uplift. So that means this thing is uplifted from this part of the river to this much height. So this is your 100 meter height, this is 400 meter height, that means it is uplifted 300 meter. So we have to calculate the rate of upliftment. It will be height is uplifted divided by age it is taken. So I have to give answer in mm per year. So 300 meter, it will be 300 to 10 to the power 3 mm divided by 30 into 10 to the power 3 year. It will be 10 mm per year. So the rate of upliftment is 10 mm per year.